So today we'll be studying about vectors. So there are different types of quantities. So there are different types of quantities. Uh, Mainly there are two types called scalars and the other one called vectors. So what is a scalar? A scalar quantity, a scalar quantity is that quantity is that quantity which only shows magnitude, only shows magnitude. Let me come to the vector part. A vector quantity, a vector quantity is a quantity is a quantity which shows both magnitude magnitude and direction. So anything which shows direction and also has a magnitude, we can name that quantity to be a vector quantity. So anything which has only magnitude means numerical value, its numerical value. So anything which only has its numerical value is said to be a scalar quantity. So moving on. So so moving on to the next question. So when can we say that a given quantity that given that a given quantity is a vector, is a vector. So the first condition, so we'll write conditions for this. The first condition is that it should it should it should have a specific should have a specific direction. It should have a specified direction. Like, is it right, left, or in terms of north, south, east, west, etc. So, moving on to the second point or the second condition, uh, it should it should obey the law of commutativity. Commutative law. Okay, it should obey the commutative law. So what does the commutative law exactly mean? So if I have a plus b, I should be able to add I should be able to add b plus a. If I add a plus b, so if I get 2, and if I add b plus a, I should get 2. So nothing but the LHS must be equal to RHS. So this is what the commutative law says, and a vector should obey this law to to so that we can call a quantity as a vector quantity. And moving on to the third rule, the most important one, uh, it should it should obey the laws of vector algebra. Vector algebra. And a fun fact or an important note is that even though a physical quantity, a physical quantity may have both direction and magnitude if it fails to obey any of these conditions, any of these conditions, we cannot consider it consider it as a vector. So let me take an example and explain. So there is something called as electric current. It has both magnitude and direction, but it is not a vector, because it does not obey, not obeys the law of vector algebra. Because it does not obey the law of vector algebra, so it is not considered as a vector. So let me change the pen color. So moving on to the next topic, uh, called as representation of vector. So how do we represent a vector? So first point is that a vector a vector is usually represented by a line headed with an arrow. Is represented is represented with a line with a line. So let's move to the next topic, called as representation representation of vectors. So how do we show that how do we show the vectors? So the first important point is that a vector is represented by a line which is headed with an arrow. So let me write the point: represented represented with a line headed with an arrow. So let me change the pen color so I can differentiate. So for example, if I have a line, and if the vector starts from here, point, let me take it as O, point O, it is representative of something of this sort. So I write the magnitude of the vector with a line in the direction of the line or the arrow, which is we usually keep an arrow on the head of that physical quantity, or the numeric value of that physical quantity to represent that vector. So moving on to the next point, that that its length its length should be proportional proportional to its magnitude. So what I mean is that if I have 1 unit as the as my magnitude, I should draw a vector of one unit one unit. So the magnitude of these two should be same, or the length of the vectors should be same. So moving on to the next point, that the arrow on the vector represents the direction. So the arrow represents represents direction represents direction. So the arrow out here usually represents to the direction of that vector. Is it north, south, east, west? So where it's moving. Okay. Moving on to some important points. Moving on to some important points about vectors, which will help us in solving questions in the future. So the first point is that if a vector is displaced parallel to itself, parallel to itself, it does not change. It does not change. Does not change. What I mean is that if I have vector A, if it displaces parallelly like this, or maybe like this, so let me call this as B and this as C. So if it displaces parallel to itself, uh, so all these vectors, vector A is equals to vector B, which is also equal to vector C. If a vector is displaced parallelly, so all of these vectors are equal. They are equal. So moving on to next point, that is, if a vector if a vector is is rotated through an angle through an angle uh, through an angle other than multiple of 2 pi, which is nothing but 360 degrees in terms of degrees, it changes. So let me change the pen color to draw the vectors. So I have a vector here. Let me name it as vector A. So if the vector, if the vector, uh, if the vector goes displaces itself by 90 degrees, so it becomes vector B. So it is usually, we can say that vector A is not equal to vector B. So we're in the case that if the same vector A displaces itself by 360, it goes around and come back to its original place. So we can say this A vector is equal to A dash vector. So the magnitude remains the same nevertheless. So moving on to next point, which is an important point, it should be noted. Uh, if if the frame if the frame of reference if the frame of reference is is rotated is rotated, the vectors do not change. The vectors vectors do not change. We have to keep in mind that magnitude magnitude can change, but the vectors cannot change. So what I mean is that let me draw a vector as, so if it is rotated, so let me, as O, and this is O dash, and this becomes vector S dash. So it's a moving frame. So the condition is moving frame. So these two vectors are equal, but magnitude, so the magnitude can change, magnitude can vary, but these two vectors remains the same. The only key note to be taken here is that magnitude can change, but the vectors remain same. So to moving on to next topic, which is called as types of vectors. Types of vectors. Types of vectors. So the first type of vector is parallel vectors. Parallel vectors. So what are parallel vectors? So parallel vectors which have same direction. So any vectors which have same direction are called parallel vectors. And the angle between these vectors is usually 0 degree. So any vector, any vector which have same direction and are parallel is called parallel vectors. Moving on to next type of vectors, that is that is called as equal vectors. Equal vectors. Vectors which have equal magnitude, s- same direction, are called equal vectors. So I have two vectors A and B. So I can, if there are so if A and B have same magnitude and direction, we can say A vector is equals to B vector.